Okay, in this video we're going to be looking at equilibrium, Le Chatelier's principle, and chemical reactions that produce a color. So we're going to get started and see what happens. So we're going to look at two magic tricks and try to figure out how they're done. Here's the first one. You have a worksheet that you're going to use to help us to turn in. So trick one went from clear to colorless, to red, from colorless to red, and the second trick went from red to colorless. So one more time. And remember, you're going to be filling out the worksheet. You might have to go back and forth on the video to get your questions answered. So here we go, play. Trick one and trick two. So colorless red, red colorless. Two chemical reactions. The magician has to wear rubber gloves underneath because he doesn't want to get that solid. He's got a little pinch of solid in his hand there. So here's what you see in the back of his backstage. And so we have to figure out what's going on. So we have solid, 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 and so we've got a beaker with water. So we want to know how we go from solid and colorless to red, solid plus red solution to colorless solution. So these are the solutions you can make with those three things, but this is yellow one, so we need to get rid of that yellow. We never saw yellow. So what combinations don't give you any new information? So if I put this solid with its solution, it doesn't give me anything new to understand. Okay. These two are different, so I'm going to keep those. These two are different. I'm going to keep those. This one, two different things coming together, so it could be a possibility. What about here? KF and KF? We can get rid of that because they're the same. What about this? Oh, new stuff. Two different things together. Alright, what about here? Is this two different things? Yes. So we can't get rid of it. It might be a possibility. Two different things? Yes. Here we got the two things coming together. One is a solution, one is a salt. So we can, it's not anything different, so we can get rid of it. So now I still have these other possibilities. We need to see what's happening. So we got rid of the iron's yellow. We need to get rid of that because it's not useful. We didn't see yellow when we did these. Is there anything else we can get rid of? Well, remember we had this yellow. We have yellow here, and we didn't see that in the experiment, in the trick. So we can get rid of all the yellow ones, okay? Because we never saw yellow. All right, we're getting rid of the yellow ones. Now we still have these possibilities. So let's see what we can figure out. Okay. We're going to see two of the remaining combinations contain the same cations, and the negative ions in the mixture do not react. So remember, negative ions are called anions, and these two anions do not react. So which ones have the same cations? We're going to click on the tiles that represent these two equivalent combinations containing non-reacting ions. So let's see. Oh, these have different cations and anions. So look at this. You've got KF and iron nitrate. Four different things that have a possibility of reacting. What about here? Two salts with different cations and anions. So these are possibility of reacting. Now we have K, potassium, and potassium. So yeah, we can get rid of that because we have the same cation. What about here? K and K. Yeah, we can get rid of those. So these are the only things that are possibilities. This, hooking up with that, or with that. So let's see what this gives us. So we have a solid, and we're throwing them into solutions. And then we have these solid possibilities going into this red solution. So we have to figure out what's going on. And I gave you observations for trick 1 and trick 2. in the data table. So we're going to try those now. Alright, trick 1. We're going to click on a solution to add the iron 3 nitrate to. So could it be this guy or could it be that guy? So let's try this one. Alright, here's the iron. And let's see what happens. Oh, so it made a red color, so that's what we were looking for, right? What about this guy? Let's click on this guy. We had solid to KF, no color change. So it can't be this combination of that and that. It's got to be this and that. So you're going to write that in your observations on trick 1. And let's click on trick 2. Here's the red. Remember this trick 2, we start red, and then we're going to add something to make it turn clear. So what about this one? Oh, doesn't turn clear. Okay, what about this guy? Oh, there we go. Colorless. That's what we were looking for, right? Let's try this guy. Oh, turns darker. Can't be that guy. Okay, so write that in your data table, and let's move on. So we know that we added 2 things together and we made red. What were those 2 things? Do you remember? We have this solid and this solution. So the solid, what am I going to put here? Is it this guy? Let's see. It was that guy. Okay, so what do we put here for the solution? What do I put here for an ion that's going to react? Is it this guy? This guy? Let's try this guy. Oh, not there. What about this guy? Is that going to react? No, they're 2 cations. They don't react. What about this guy? Anion. And then remember it was adding to the iron. There we go. So you need to write this for your net ionic for one of the reactions. Iron 3 plus and thiocyanate. And then we need to know what this red guy is. So what would 3 plus and a -1 make together? So plus 3 minus 1. It's going to be this guy, right? It couldn't be this guy because plus 3 minus 1 doesn't make a plus 3. And plus 3 and minus 1 doesn't make a plus 1. So let's try this guy. Good. So that we figured that out from the charges, okay? So you're going to write this down on your conclusion page. So now you're going to see what it looks like as molecules. So this is water. There's a bunch of this in the solution. There's some green guys, which are iron, some thiocyanate, anion, and then this is when these 2 hook up together. It gets really big, and these guys are waters that surround it because it's aqueous. Okay, here we go. So you might have to rewind my video and see it because sometimes it's hard to see the first time you look at it. But there was the hookup of the thiocyanate with the iron. Okay, and then there's water surrounding it. So let me play it one more time so you can see it. Bunch of waters, and here's the hookup. Alright, and then it changes the color. Now let's see what it looks like when it dissociates. So this is when this big old guy that we just made breaks into the 2 pieces again. That's called dissociation. So now it broke into 2 pieces, and water's still bouncing around there. Alright, so now here is the here it is again, so you can see it maybe a little bit better. So break, coming together, breaking apart, back and forth, back and forth. That's what this means. It's going back and forth in equilibrium. Alright, so the red color disappears when the solid KF is added. So let's watch this one. We got fluoride hooking up there. So let me show you guys that again. The fluoride displaces replaces the water and then gives off the free iron 3+. So what's the colorless product? We got iron 3+ and 5 fluorides. So what would that make when it hooks up together? +3 minus 5. What do you think? +3 minus 5. Does that make a -4? No way, Jose. What about a -3? No. How about a -2? Good. So you're going to put that in there for the trick 2. And make sure you have a K in there when you answer the question. And let's see what's next. Okay, so we've got this competing equilibrium depending on what we add to the solution. If we're over here on this side, we're the red side. We're over here, we're the colorless side. So let's watch this and see how it goes. So we've made the equilibrium go towards the colorless side by adding the by doing the trick by adding the fluoride to that. So when we add this fluoride, we make it go colorless. So we've messed with this equilibrium right here because we are getting rid of this by reacting it with fluoride and turning it into this. So we've gotten rid of this. So the reaction is going to go in this direction to make a more colorless side. So here's a summary, and you'll need this for your conclusion and summing up so you know what's going on. And then you're going to try question number 3 there on the summing up. And then we're going to try the self-test together. I'm not going to give you the answers for the self-test, so I want you to try it. But I'm not grading this little self-test. I'm grading your lab report that you're going to submit as one PDF. So look at this, see if you can figure out what we're going to do. This is our little self-test. And I'm not grading this, but I want you to see if you can figure out what's going on. So I'm not going to talk through this, I'm just going to let you read, and then I'm going to click the next. So choose which one you think we need. Oh, not that one. We need these guys. We need the H pluses. Going from orange to yellow on the second part, I need to get to this side. So do I need an acid or do I need a base? Acid? Oh, no. Base? Yes. Okay, you made it through this lab. Make sure that you fill out the lab report completely, the worksheet that goes with this. It's pages 25 and 26. It's called Equilibrium Changes the Chemistry of Magic. And I'll talk to you soon. Bye-bye.